This is a video about increasing and decreasing functions, and it's an example video over increasing and decreasing functions. It's a little bit more of a complicated problem than what I did in the last video, and I want you guys to see that and how you would accomplish that. So if you don't know what increasing decreasing functions is, I would recommend going and watching that other video so you get more of an explanation, because I am going to assume that you kind of know a little bit more what you're doing in this video than in the last video. I'll still explain stuff, but not as detailed. Okay, so increasing, decreasing functions. Here is a problem that we're going to use, and I know it's just a binomial, which makes it look really simple, but the fact that it's x to the fourth means that we're going to get a function that has more curves in it and more spots where it's increasing, decreasing, and more critical values. So I can actually graph this out for you if you give me just a moment. Oops. Okay. Here we go. So this is what this is going to look like. And you can see that we already know it's going to be decreasing here, increasing, decreasing, increasing. So we have more values here that we have to look at, and that's what makes this more complicated of a problem. But it's the same idea. You just have more intervals you have to look at, really. Okay, so let's find our derivative. So we know f prime of x is going to be equal to 4x minus, I'm going to take this 2, multiply it by the 2, so that gives me a 4x. Sorry, this is a 3 right here. This is x cubed. So now I'm going to set this equal to 0, minus 4x equal to 0. Factor out a 4x. And now this is just like your zero product property. I believe that's what it's called. And I'm going to set this 4x equal to 0. And I'm going to set our x squared minus 1 equal to 0. So here I am going to divide out this 4. X is going to equal 0 for one of my critical points. So I'm going to call this x to the first. Or actually, sorry, not x to the first. I'm not going to do that now. Never mind. And then this one, I'm going to do x squared equals 1 square root that, which means I'm going to get plus or minus 1, so x is 1 and x is negative 1. Okay, so with this, because we have more critical values, these two here and these two here, we're going to have more intervals, because if you remember, our critical values map out in what intervals we're looking at. So I am going to rewrite these up a little bit higher so I have more space to work. So let's just rewrite these up here. Okay, so we have x is equal to 0, x is equal to 1, x is equal to negative 1. Oops, this looks off. Negative 1. Okay. These are critical values right there. Next, I'm going to make out my chart. So interval, I'm just going to write that there. Interval. Next we have our test value. sine of f prime of x. Actually, I'm going to give this one more space because I'm going to have work to do in here. Then our conclusion. Okay. So, first part is we need to know our intervals, of course. Okay. Right here. So our first interval is going to be from our lowest critical value to negative infinity. So we are going to go from negative infinity less than x, which is also less than negative 1. Okay. That is our first interval. Our second interval is going to be the next to the smallest value to our second largest value, or second smallest value. So we're going to take our negative 1 because that's the smallest. Then we're going to look at 0. So really, in a sense, you could consider the infinities, your negative infinity, your smallest value, your positive infinity, your largest value, and you're looking in between those two. So I'm going to take negative 1 less than 0, or sorry, it's less than x, which is less than 0. Next, we're going to do the same thing, but using the next values. So we're going to look at next smallest, which is our 0, in between our largest, which is 1. So 0, x, 1. And really this does make sense. You're looking in between your critical values, your points, and it wouldn't really make sense to look from negative 1 all the way up to, if this critical value was 5,000, when you have a number like 5 in between it. It wouldn't make sense. You might as well just break it up, because otherwise you're not really going to know in which interval your answer is at. Okay. And then finally, we do our negative 1, or sorry, our positive 1 is less than x, which goes off into infinity. Sorry, that one's a little bit cramped, but there's a lot in here. Okay. So, now I'm going to look at what test values we can use. So, smaller than negative 1, I can use I'm going to set x equal to negative 2. Here, a value between negative 1 and 0 could be negative 1/2. A value between 0 and 1, I'm going to set that equal to positive 1/2. And 1 to infinity, let's just do 2. Keep these values small so it's easier for you to do your calculations. Yeah. Okay. So next we're going to do f prime of x, or sorry, f prime of our test value, which is a negative 2. So this will be equal to 4. Let's write this on the next line so I can fit all of it in. 4 times negative 2 to the third power minus 4 times negative 2. Okay. This is going to be, I'm just going to solve this on my calculator right now, really quickly. Okay. Which is going to be x is going to, or f prime of negative 2 is going to be equal to a negative 24. Okay. our next number is 1/2. So do the same thing. Just solve for it. So I'm getting x is equal to, or f of 1/2. Negative 1/2 is equal to, let me write this out for you, f prime negative 1/2 3 minus 4 to the negative 1/2. Again, sorry this is cramped, there's just a lot of writing. And this is going to be equal to 1.5. Next, f of, I want this to be 1/2 right here. That just makes it easier to do. F of 1/2 is going to be equal to f of 1/2, f prime of 1/2, sorry. Let's make that clear. 4 1/2 cubed minus 4 times 1/2, which is equal to negative 1/2. Write this like that. It doesn't matter how you write it. Normally in calculus, they prefer that you use improper fractions because they're more precise. For this, I'm just going to write it like that. I guess that one's different, but that's okay. For this, it's not mattering a whole lot. And then we're going to use 2 here. So f prime 2, I'm just going to write this instead of writing it all out because you know the drill right now. And it's going to be 24. Okay, so as we can see here, this is a negative number. Negative number means it's decreasing. So decrease. This one's positive, so it's increase. This one's negative, so it's a decrease. And this one's positive, so it's increasing. That's all there is to it. The only change really in here is how to find your intervals. Basically, you just go from your smallest and negative infinity, and then you go to the smallest and your next smallest. The interval is that, so on and so forth. That's all there is to it. Same thing as a simpler problem. And yep, thank you for watching this video.